Alright, today we're going to work on the algebra of functions. So, for example, well, let me read the title first. Algebra of functions. So, just the four basic binary operations: addition, subtraction, multiplication, and division using function notation. And this isn't really anything new. It's just treating something that we already know how to do a little differently, just a little different notation. Let's say we have f of x equals 2x squared minus 3x plus 2, and g of x is x squared plus 2x minus 8. Well, it'd be easy to say, what's f of x plus g of x? Well, then I'll just add these things together. But function notation allows you to say maybe not f of x plus g of x, but f plus g of x. So all this is saying is add the function f and g together, and your functions are with respect to x. So x is my input value, and I'm adding f of x and g of x. So this is the same as f of x plus g of x. So it's exactly what I'm going to do. I'm just going to add these things together. 2x squared minus 3x plus 2 plus g of x, x squared plus 2x minus 8. Let's combine like terms. 2x squared plus x squared is 3x squared. Negative x, negative 3x, positive 2x is negative x. And positive 2 minus 8 is negative 6. Therefore, f plus g of x is 3x squared minus x minus 6. Just to discuss the domain of f of x, the domain would be all reals. The domain of g of x would be all reals. Therefore, the sum of these two would also be all reals. Just be careful when you're subtracting. Let's say we have f of x is the same function, 2x squared minus 3x plus 2. Let's call g of x the same function, x squared plus 2x minus 8. What is f minus g of x? Well, that's simply asking me to take f of x and subtract g of x. Be careful with this negative. We're just going to open up a set of parentheses to remind ourselves to distribute. So let's say we have 2x squared minus 3x plus 2 minus all of g of x, which is x squared plus 2x minus 8. Distribute the negative. 2x squared minus 3x plus 2 minus x squared minus 2x plus 8. Just distribute to all three terms. And now we'll combine like terms. 2x squared minus x squared is x squared. Negative 3x minus 2x is negative 5x. And positive 2 plus 8 is positive 10. Alright, there's addition and subtraction. Now we'll do a little multiplication and division. So let's say we had f of x is 2x squared minus x, and g of x is x minus 1. Let's find f g of x. Well, there's no operation between. Just like you have no operation between 2 and x, well, that means multiply these things together. If there's no operation listed, then the operation is multiplication. Just like 2 radical x. There's no plus or minus sign between, there's no division sign, so the operation implicitly defined is multiplication. So this is just saying take f of x and multiply g of x, which in this case is 2x squared minus x times x minus 1. So we just have to FOIL these things out. 2x squared times x, 2x to the third. 2x squared times negative 1 is negative 2x squared. Negative x times positive x is negative x squared. And negative x times negative 1 is positive x. I just FOILed these things through. Combine like terms. 2x to the third minus 3x squared plus x. So that is f equals f times g of x. And the last operation would be division. So again, let's say f of x is 2x squared minus x, and g of x is x minus 1. Let's find f over g of x. Well, this is just a fancy way to say what is f of x divided by g of x. So that's exactly what I'm going to do. I'm going to express these two as a fraction. Well, that would be 2x squared minus x over x minus 1. So we can simplify this fraction, and we have a GCF of x and the denominator cannot be simplified, so I cannot cancel anything. But just be careful, because a lot of the times you will be able to clean this up. In this case we weren't able to, because everything's multiplication. We don't have exact terms to cross out. Just be careful with the domain here. The domain, all reals. Domain here, all reals. But this domain, that is not all reals. That's all reals for all x, such that x cannot be 1. Because now we have a denominator. Before we did not. That's why the domain was all real, so there was no denominator. Here, there is a denominator, so just exclude the value that would give you a 0 in the denominator.